So, hi all, I am Parampreet Singh and I have been taking MLB sessions this term, and today we have following all the sessions. Today we have like a session number 14, and today we will cover some very important concepts in machine learning pipeline steps, mainly the machine learning workflow, that is like cross validation and hyperparameter tuning. These two are very important concepts, cross validation and hyperparameter tuning, as they help a lot in uh, making our machine learning models robust, like uh, more better models, we can say. So, as always, I will upload the recording in my YouTube channel. Um, this is my YouTube channel, you can subscribe to it. Alright, I will upload the recording here. So, let's start. Okay, let me add the data sets as well. So today, for the cross validation and hyperparameter tuning, we will consider this house price data set. Okay, let me upload it. And regarding the classification stuff, we will also look into classification, mainly the classification metrics like uh, accuracy confusion metrics and precision recall, and then based on that F1 score. So it will after the end of by like doing today's session, after the end of today's session, we will able to we will cover all the concepts of week 5, as well as mostly all the concepts of week 6 also. Okay. So and this Titanic machine learning from disaster, this is a classification problem competition, and I'm using this dataset as well. This is for the classification metrics. Yeah. So I have loaded both of these datasets here. So let's start. Is the font size clear?
Yes, it's
Okay.
clear.
So first we will start by loading up the dataset. So let's load the dataset here. I'm just loading the train dataset only as a name of df pd.read underscore csv, and I will copy this path here, and then df dot head. So I have loaded this dataset. I am setting, and I will set the index call id as the index column. id. Now we have all these columns. We have a lot of columns, like 80 columns we have, and the last column is the sale price. So what I will basically I will do is let me just check all the numerical features. All right, I won't do any processing, or we won't do any kind of pre-processing or anything today. We will simply let me drop all the null values, okay, and some other columns as well. So let's first take all the numerical columns only. So okay, directly we can take the data set like this. X equals df dot select data types, exclude equals object. So by this we will have only the numerical columns, and I'm taking the sale price, which is the target label, as in y. So now I will see the data set, how it looks. So we still have 37 columns. So let's first look into do a little bit ADA, and let's see how many null values do we have. So we have 1200 200 null values here, and we have total 1460 entries. Okay, 1460 samples. So we have a little bit of null values, at max 200 null values we have. all right. Okay, not 200, 250 plus something. So I'll simply drop all the null values, all right. So that would be a better approach. Let me drop it here directly. uh, df dot drop na. Okay, not here. X dot drop na. um okay, let me df equals load object. So this will be the my updated df and drop na. Yeah, that will work. And now I will have my complete data frame until like drop columns equals sale price. So now if I check on my dataset X, then I will have these 36 columns, and like it doesn't have any kind of now null values. If I check once, X dot is na dot sum, and again if I do sum, I'll get answer as 0. So that means I don't have any kind of null values, and I'm only selecting just for this cross validation and all this stuff. I'm only selecting all the numerical columns, all right. So till now, is this like all clear? Whatever steps I have done, these are some basic steps. Is this clear, guys? Like I have selected only the numerical columns, and I have dropped the uh, rows which contains some null values, all right. And I'm like separating X and Y. So is this clear to you all? You can give a thumbs up, or even you can speak up as well. So then we move on. So let's move forward. Now, okay, nothing else. We can even like split out the data set, or we can, in fact, okay, yeah. So let me write on this also, this split. Yeah. Okay. So, what is cross validation? Anybody knows? Anybody wants to like tell what is cross validation? Um,
It's to check again the splitted train data is not a fluke.
okay.
To cross check
Yes.
again and again with different data.
Right. Yes. So cross validation is mainly like generally we have two data sets, right? Train and validation data sets, right? Let's just forget about the test data set, because in data set we don't have the target label on which like we can evaluate our model. All right. So we have only these two data sets, which are train and validation sets. So what we generally do is we train the model on training data set, and we do the predictions on validation data set, and we evaluate our model by certain metrics, let's say R2 score, mean squared error, mean absolute error, something like that, right? uh, but the thing is, this is just what we are taking is we generally take some proportion of our original dataset as a validation dataset. Okay, let me show you here. So let's say we have, okay, so let's say these are the number of rows we have. Okay, I don't know what happened. Yeah, yeah. So this is like from 1 to 100, you can say. Okay, whiteboard is not working properly. Let me reload it. So all right, what is happening? It is again and again. So we have like, let's suppose 1 to 1000 samples. All right. So we have 1000 samples, and this is our like complete our X or the whole data set. Okay. So what we generally do is to evaluate our model. we separate some amount of data into a validation set and some amount of data for training data set. So this is for like the training and this is for validation. Okay, yeah. So this we generally do, and we do it in like various proportions, let's say 70 to 30 or 60 to 40 or in fact 80 to 20 as well, right? So this is what we generally do. Okay, I don't know what is happening. Let me connect it again. माउस इज वर्किंग प्रॉपर्ली, कुछ इशू इसी के साथ ही वाइट बोर्ड के साथ. Yeah, so okay, so this we generally do, right? So doesn't matter how much we like shuffle and split our data set, of course we get almost the same proportion in like same distribution in training and validation data set, but still like we are training, let's suppose we are training the data set on 70% of the data, and okay, rest 30% of the data we have like for the validation set, and we are validating our model only on this proportion. So this is just a normal validation which we do. Now there's a concept called cross validation. Okay, what is cross validation? It's simply like, okay, yeah, what is, I hope now it works properly. Yeah, okay. So ऑल राइट, अभी भी कुछ इशू हो रहा है. I hope now it works. So we have this data set from, let's suppose, 1 to 1000 rows, all right, and we generally split it into two parts. With first is a training and second is validation data set, all right. Let's suppose we split it into 70 to 30 ratio, 70 in training set and 30 for the validation part. So this is generally we just validate our model on the 30% of the, like, on some proportion of the data. This is like हम model को एक ही basis पे we are evaluating, right? Like on some certain part of our data set. So let's suppose so there is a technique called cross validation. Cross validation. What we do in cross validation, let's suppose I have set k equals 3. Abhi ke liye just like take it k as a just like bear with me. What this k equals to 3 means, and k equals to 3 generally, okay. So we take the same data set, all right, 3 times, but because k is equal to 3 as well, like one more thing I will do, like we split the data set into, let's suppose the CV as well, the k equals 3, okay, there is no much difference. No, I am writing using a pen, using the pen tablet, which like website mein issue tha. Yeah, I don't know the software. Okay, so what we generally do is, let's suppose CV is also 3 and k equals to 3. So k equals to 3 means we take 3 different sets. Okay, we take the data 3 times. Okay, the same data 3 times. All right. Okay, not that k, sorry, that is CV, not the k. Yeah, CV equals to 1 means this, CV is 2 means this, and CV equals to 3 means this. Now what is k? K means we split the data set into 3 parts, all right. So let's suppose I have splitted the data into 33, 33 and 33 ratio, all right. So 33, 33 and 33. So in these ratios, I have splitted the data set. And in cross validation, what we do is we take like out of these 3 parts, we take 1 part for validation stuff and rest of the 2 parts for the trading. All right. and then we evaluate the score of this validation data set. Okay, after training the model on this data set, this one two. All right, then this is for the CV1, and we have CV3. Then what we do in CV2 is we take we split the data set into same three parts, but this time what we do is we take some different set as a for the validation data set. Let's suppose we take one for one here as a validation data set, and rest 2 and 3 part, the second and third part for the training. And then again we train the model, uh, like from scratch we train the model on this dataset 2 and 3, and we uh, evaluate our model based on this validation dataset. Then again CVs 3, so we again split the dataset into three parts, and this time we take these two 1 and 3 for the training purposes, and this second part of the dataset for validation stuff. And by this we get three scores, right? Three evaluation scores, or like let's suppose we are taking R2 score as a metric. Okay, so we get three R2 score. First one is this, second from here, and third from here, right? So this is what we do in cross validation, and how it helps our model. Basically हम जो है मॉडल ट्रेनिंग करते हैं डिफरेंट डेटा सेट, मतलब डिफरेंट पार्ट्स ऑफ द डेटा सेट, एंड वी इवेल्युएट आवर मॉडल ऑन different validation stuff, and then we reach like we get a better understanding by looking at the uh, like these metrics, जो भी हमारा टेस्ट सॉरी जो भी हमारा एरर स्कोर आता है और द लॉस which we get a better understanding of our model. All right, so on the basis of only one validation data set, we can obviously judge our model, but if we have to judge our model properly, then it is better that we use the cross validation. Okay, and one more thing, in cross validation we don't have to specifically, like we have so many good like scikit-learn APIs, so that we don't have to split our data set into different training and validation data sets manually. The scikit-learn, there are some functions in scikit-learn which do it automatically, so we just have to pass the X data set. Okay, we don't have to split the data set into X train and X test or X valid by using train test split. Okay, we do this manually for or only if we have a one validation data set. So this is like the underlying concept and how it works, the cross validation technique. So is this understood? Like, is this clear how cross validation works? If anybody has any doubt, you can ask. All right, so let's move forward. We have like various cross validation techniques. First one is the basic one, which is train test split. We split our data set into two parts, X train and X valid or X test, and then we train our model on training data set, and then do the evaluation on validation or test data set. So let me show you the first one. Okay, so let's first import the required libraries from sklearn. Let's use the linear regression only as of now. All right, so we will be using the linear regression, and for the train test split we generally do it from like using model selection. We use the train test split from model selection and all the other validation techniques as well. So what I will simply do is I'll simply write something like this: X train, X valid, Y train, and Y valid, and here I will simply pass the train test split, and I'll simply pass the data set as well as by default. Okay, so I'll also pass the test sizes, let's say 3, so it's 70% in training data set and valid in 30% in rest of the in validation data set. And let me set the random state as well. So random state equals, let's suppose 7. So if we see the shape of the data set of both, so this is how we got these two data sets. And what I'll do is let's simply train a model. So model equals linear regression and model dot fit, and we train the model on training data set. All right, and after training we simply evaluate the model. Okay, I'm simply using the score parameter here, so I'll simply pass x valid, okay, and y valid. It will give me the evaluation. It just gives me the evaluation on this data set. All right, on this x valid data set. So this is like हम बस एक बार ही हमारे मॉडल को इवेलुएट कर रहे हैं based on some specific portion of our data set, right? But in cross validation we can do the thing on different portions of the data set. So and yes, in cross validation we have various techniques. The technique which I have shown you here, okay, from where like we have learned this concept cross validation, this is called okay, KFold cross validation. KFold cross validation. All right, means we create k separate fold. So these, like, okay, let's suppose if I set k equals to 5 and I have this data set. If I have k equals to 5, this means our data set is splitted into 5 equal different parts. Okay, and the number of CV we pass, CV is the how many times we have to do the cross validation. Let's suppose generally we pass the k and CV as in same number. Okay, like agar hamara, so that we can cover up all the portions. So let's suppose if I pass CV equals to 3, so I will have the same data set. All right, like I will do the cross validation 3 times on the same data set, but we have like different data for the validation each time, and the different data for the training, like in all the cross validation parts. So let's suppose the first 4 are for training, so let me write it as train, and the last one is for validation. And this time let's suppose this we have for the validation and the rest are for training. So this is how KFold cross validation works. So is this understood, the KFold cross validation? um, okay, all right, so let's just look into it. So we, as I said, we don't have to split our data set, so we can take our directly our x. Okay, so how to use the k-fold cross validation? Again, the all the cross validation techniques are in model selection itself. So I'll simply write k, and I'll write k-fold here. Also I will use a cross val score as well. Okay, and what this cross val score is, I'll show you. Okay, so if I open it, yeah. So in KFold by default the split is 5, means by default it will split the dataset into 5 equal parts. Okay, and so I'm simply taking the direct KFold. Okay, and oh, all right, so like we can apply these different cross validation techniques using this cross val score, okay, on a model. So we have to use this cross val score, or else we have to do it manually. Okay, in the cross val score, what I will do is I simply pass the estimator, that is the model. I'll call the linear regression class here. Okay, then the second thing we have to pass is like x and y, obviously, which on basis of what we have to train the model. Okay, we don't need to, like, yeah, so x and y, then we can pass like all right, so by default what it do is, okay, so there are various techniques. So one is stratified k-fold. Also I will explain you the stratified, what this means is, okay, in just a minute. So to use the k-fold cross validation, we simply pass cv equals k-fold. All right, I'll call the k-fold class, and it is like n split is 5, so it will do the cross validation 5 times. And other than that we don't have anything else. So let's take the scoring parameter as mean square error. Okay, so negative mean squared error. So I'll explain you all the things in just a moment. So if I run it, you can see I get 5 different scores. All right, so these are like 5 different mean squared error on the 5 different validation sets which we have made, and did the cross validation. All right, so this is how we do this, like we do the cross validation in code. And now what is the scoring parameter here? Like we have various metrics, R2 score, mean absolute error, mean squared error, and RMS is something like that. Okay, and there are more metrics like that. So we can pass a specific metric here. Okay, on based on what metrics it should score the, it should evaluate the model. All right. So if we want to pass any like the normal mean square error or mean absolute error, these metrics we have to like add a prefix called like add a prefix named neg underscore. This represents the negative. Okay, it just gives us the score in negative. We don't have to like no need to worry like why this is giving us the score in negative. It is just for the it's like implementation. This is how it is implemented under the hood, and we can simply take the like positive values of it, all right, by just multiplying it with the -1 or setting up minus as in front. Okay, these scores which we got, and we have like various metrics. So as I told you, okay, let me put it in this CV. Yeah, so now if I write, this is the cross validation score which we got. Now let me create another one, and this time I will take the mean absolute error. Now if you see, this is the mean absolute error we are getting for 5 different KFolds. If I set the n split equals to 3, okay, then it will do the cross validation on 3 folds of the data set. Okay, 3 partitions of the data set. And now there is, let me show you the R2 score as well. So for the R2 score and for some metrics, we don't have to pass like the we don't have to add the negative this prefix in the scoring parameter. And if I simply run it, all right, I'm getting okay. For R2 score, it is, I think, yeah, R2 directly. Yeah, it is R2, not R2 underscore score. So this is how we can evaluate our model based on the R2 score. Now, one more thing here, we can also pass the metrics, like either we can pass by the string or we can pass the metrics directly. How? Let me import the mean absolute error from sklearn.metrics, mean absolute error. All right. So what I will do is I'll simply copy it and I'll simply pass the metric here. So okay, I think I have to, yeah, I have to call this scoring value looks like metric. Oh, okay. I have to create the metric into a scorer. Basically, I have to wrap it in another function as well. So we can do this scorer. Yeah. So if we want to pass the mean absolute error as a like direct metric, not the string value, I'll simply write make scorer, and in between as the first parameter I will pass mean absolute error. So by this also we will get the same value which we were getting if I write it here, negative mean absolute error. All right, so this you can see the scores are same, just that the scores are in negative because we have to pass in the like the negative prefix. If I don't pass negative prefix, I'll get the error. All right, this is because the metrics are like are in the name, metrics are with the prefix negative. Okay, so yes, one more thing, we can get the matrix names as all the metrics as well, like in the string values, so that okay, I'll show you this in just a moment. Yeah, if we want to see like what values we can pass in the scoring parameter, you can get this via get score names function, okay, in the matrix library itself, module itself. So I will simply call this function here get score names. Okay, if I run it, yes, now you can see here I am getting a lot of metrics. So you can see the mean absolute error, mean squared error are in the negative prefix. All right, and we have various other metrics as well, like precision recall, R2, ROC, AUC curves as well, and the F1 explained variance also, um, and the accuracy also. All right, so there are various metrics we can pass in. That also depends upon the problem which we are solving. We are solving a regression problem or classification problem. The evaluation metrics depends upon that. So this is just like how cross validation happens, and we have like various cross validation techniques. The one which I have explained you here is the KFold cross validation. All right, and then we have one more cross validation technique which is similar to the uh,
Hello.
stratified. Yeah. Yes.
I have a small confusion. Like inside KFold, you
Mm-hmm.
have given three in the notebook. So
Right.
this parameter is only like for the number of entries. Like here we have received only three array of three elements. It's only
Yes.
for that, right?
Yes, see, by default it is 5. So we are getting 5 score. 5 means we are splitting the data set into 5 proportions. Okay. And the 4 proportions, based on the 4 proportions, let's suppose say these, on these proportions it will do the training. Okay, the model will train. And on this last proportion it will do the evaluation. Like it will calculate the provided score. Like for this one, it will calculate the
Yeah.
mean squared error and it will show it here.
Okay. Like I understand that, but
Mhm.
can you show that whiteboard once? What? Yeah.
Yes.
So here, like CV is equal to three. It was given like here. So we have only made three. We will check only for three times, right?
Right.
And K-fold for different. Like we have divide the data set into five parts.
Right.
If K-fold is equal to five, we divide the data set into five parts, and
Mm-hmm.
CV is equal to three. We will check it for three times, right?
Right.
Okay.
Here I have written it like this, but generally, as I told you, in the KFold, like if we pass on the whatever the n splits we pass on, like here we have by default the value is 5, so it will do the 5 times cross validation. All right, so it will take all the 5 combinations of the data set and do the uh, evaluation. Okay, do the cross validation.
Okay. Yeah.
All right, so yes, okay, so there is one more technique which is stratified k-fold. What this stratified mean is, generally the k-fold will split the data set. All right, but it does not maintain the distribution of each of the like it does not maintain the distribution of the target level mainly. Okay, so to maintain the distribution, we use the stratified k-fold. All right, and by default also the crosswell score uses the by default the crosswell score, this function uses stratified k-fold. So generally, if you have to do the cross validation, it's better you use the stratified techniques, okay, rather than the normal the fold or any leave one out or something like that, because the stratified will keeps maintains the distribution, and that will give us like some better understanding of the model of the scores mainly. Okay, and our model will learn also like better and do the evaluation more robust, because our target label is uniformly distributed, kind of. The distribution in the validation set and the distribution in the training set will be the same. Okay, so that's what the stratified do. um, Now we have like various cross validation techniques, as I told you. I'll show you one more technique, which is this leave one out. What leave one out do is, let's suppose uh, okay, so in leave one out, what happened is, let's suppose we have 1 to 100 samples. In leave one out, it will like let's suppose it will take this second sample, and it will use only this sample for the validation, okay, for evaluating the model, and on the rest 99 samples it will train the model, and then again it will do for the third and the fourth and so on till 100. So this is how a leave one out cross validation happens. Okay, like in the KFold we get the proportions, all right, we get the different k different proportions of the data set, but in leave one out we can have like different samples. Okay, we can evaluate the score on different samples. So this is how LeaveOneOut works. And then again, similar to LeaveOneOut, we have one more cross validation technique, which is LeavePOut. P basically represents the number of samples which we have to take for the validation. If I set the p value as 5, so it means it will take the subset of 5 samples, let's suppose 5 to 10, okay, these 5 samples for the validation set, and rest 1 to 4 and 11 to 90, sorry, 11 to 100 samples for the training. Okay, this is how LeavePOut cross validation works. So this is just the basic difference in the various cross validation techniques, and there are also, like, there are other cross validation techniques as well. For the time series data set we have different kind of splitting techniques, the cross validation techniques, but I'm not going into that, like, just to give you a simple overview how cross validation works, like, so this is like the simple overview. And how can you like take the, like, consider how much score it is giving. Okay, so आपको एक ऐसे clear होगा कि how can you mainly evaluate the score. What you can do is you can simply take the mean, okay, mean of the score, and by taking the mean you can get the average value, like whatever the average score you are getting. Then like here, okay, the scoring is in the R2, so we are getting the, okay, leave that one. So like आप ऐसे 5 आपको scores मिल जाएंगे, then आप how will you consider, like, आप एक score कैसे निकालोगे. You can simply take out the mean. You can also like use other metrics as well, but generally checking the average score is like more recommended than like checking each of the score. And then again, to do the predictions and all, we can simply do the predictions as well. Okay, let's suppose if I pass an X valid, okay, sorry, not on the CV, sorry, CV is for the cross validation only, it gives us the score, not any kind of estimator. We can then train our model based upon that. Now like within the cross validation only, what we can do is we can simply do the cross validation on various parameters of the model. All right, so let's suppose we are using the SGD regressor, which is like linear regression but with the gradient descent, right? So we have hyperparameters in the gradient descent, something like this. The learning rate, we have the hyperparameter, right? So learning underscore rate, and we have other hyperparameters also, like the alpha values for the penalties, which are the okay, the penalties are okay, let me write it here, that would be better. CD regressive. So okay, now this comes under the hyperparameter tuning. Let me write this one. So this is the like SGD regressor, which is the linear regression itself, but implemented in gradient descent way. Okay, so we have various penalties which are okay, I forgot the actual name. Yeah, which are like the regularization techniques, like L1 or L2, the ridge regularization, or the lasso one. All right, and we have various hyperparameters in this, like the loss function which we have to use, which we can use, or the penalty, or the alpha values. Alpha values are for the same penalty which we have passed, and then other values as well, something like the maximum iterations and the tolerance value, the learning rate, basically eta 0. Okay, so these are the learning rate, like this is the learning rate, and these are like the various parameters which we have. And like as I told you, like as we have seen in earlier sessions, mainly in linear regression we have this learning rate parameter, okay, which basically tells us how long or how short steps should we take, all right, to do the gradient descent, right? So if we have some higher learning rate, the alpha value is, let's suppose, say 5, then it will take bigger steps. If we have alpha values some smaller, let's suppose 0.01, then it will take smaller steps to reach to the minimum, all right. So these learning rates, this is a hyperparameter, and to identify which value for the learning rate is suitable for the model, we can do hyperparameter tuning. Like how, let's suppose we have a array, okay, which basically stores different learning rate values, okay. Let's suppose 0.001, 0.01, 0.1, and 1 and 2, okay. These are various learning rates, and we call our model, and we call and train our model on each of these values separately, and then we evaluate the score. This is how we do the manual hyperparameter tuning. So this is the basic underlying concept, and by doing the hyperparameter tuning we can identify which value gives us the better evaluation score, and we can use that uh, that value only for training our model, all right. So okay, yeah, so this is how we do the hyperparameter tuning. Now there are various techniques, GridSearchCV, RandomizedSearchCV. We will go into that as well, but let me first show you the manual way. Let's suppose I have set some learning rate values here. So let's say 0.001, 0.01, and 0.03, and let's say 0.1, and then the 1 as well. So what we will simply do is, I will go through each learning rate. I'll simply create a for loop here for rate in learning rate, and I will train my model on it. So model equals SGD regressor, and here I will pass the eta 0, which is the learning rate parameter, as the rate, okay, whatever rate value we have for each of these values. And then I will fit the model on, simply we will take the manual data set only as of now, and then I will compute the score here, okay. So let's say we will compute mean absolute error, okay, mean absolute error. And okay, let me do the predictions as well. Y predictions, which is model dot predict x valid, and here I will pass y valid and y preds. Then I will get the score as well. Now what I will do is, I will simply print it, okay, learning rate, which is my best rate, and then the score, which will be yeah, okay, score. So I'll simply print it out here, and by this, like, we can identify whichever value, whichever learning rate gives us the lowest score, we can consider that. All right, learning. Yeah. So now if I run it, you can see for the learning rate 0.01, I am getting this mean absolute error. For the learning rate 0.01, I am getting this, and for the 0.03, I am getting this this score, and 0.1, I am getting this score, and for the learning rate 1, I am getting this score. So by this, like, we can identify which one has the lowest score. Now this is just a very rough manual work. What we can do is, I'll simply create a dictionary, okay, called scores, and in this scores dictionary, what I will do is, okay, let me write it here. What I will do is, I'll pass the learning rate as the key, okay, and its score value, and the score for that specific learning rate as the value for that dictionary. And after that, I'll simply look into the scores dictionary. If I run it now if I check the scores dictionary here, you can see I'm getting all these values here. Now to check like which learning rate has the lowest score, I can simply call the minimum function here. So minimum, and then here I will simply pass the scores dictionary, not the scores dictionary exactly. I will pass the scores dot items. Why? Okay, let me show you. This is my scores dictionary, right? If I do scores dot items, I'll get uh as a like list of items. Okay, the first item will be the key value pair, and the second item will be the second key value pair, and so on and so forth. And on this scores dot items, okay, I'll pass in the key as well. This is just to check to find the minimum value. Okay, I'm passing the key. You can even copy this code as well. So for each key, I will consider its value. Okay, key equals, okay, not the key, I have a pair, right? For the pair, I'll consider the second value, which is this one. Okay, which is at the first index. Now if I run it, you can see I am getting the lowest score uh, in the with the learning rate 0.01, which is the first one learning rate here. Okay, now let's suppose if I set some more learning rates here, 0.001, 0.003, something like that. Now if I run it, you can see I'm getting various scores here, and these are the scores here. Now if I check the minimum score, okay, this time I'm getting 1e minus 3, you can say, or 0.0001. Okay, so this is the best alpha parameter, or the learning rate, or the eta for our SGD regressor, we can say, because it is having the lowest score. All right, so this is how we generally do the hyperparameter tuning, and this is just the basic hyperparameter tuning I have shown you in a manual way. So is this clear to you all? Guys, is this clear, or do you guys have any doubt? You can even,
It's clear.
okay, see, okay, so now what we do is, okay, let me take on this, I'll simply copy this and let me paste it here. But this time what we will do is, rather than like doing all this stuff, I'll use the cross validation in it. Okay, how? Okay, CV score equals cross val score, and here I will pass the SGD regressor with the provided learning rate. Okay, eta 0 as a rate, whatever learning rate which we have passed here, and then I will pass on the data set, which is the x and y value, and then I will, let's say I'll take the mean absolute error only, so negative mean absolute error. All right, and CV equals to 5, I will set, that means 5 times cross validation we will do, and by default it will do the StratifiedKFold. Okay, and I'm taking the negative of it so that we'll get the positive scores, and the score I will compute as the mean score. Okay, the average score of all the 5 folds, and for each of the learning rate. Now you will see it will take some more time. Okay, I'll show you. So now if I run it, okay, now okay, of course काफी jaldi it ran, but it still took some time. If I show you here, if I run it here, now you can like here you can see I'm getting the values very fast. Okay, the model is training very fast, but here if I run it, you will see like there's a little bit like थोड़ा सा milliseconds का difference होगा, like 0.013 and all the others. There's a slight difference because it is doing the cross validation as well. If I set the CV equals to 10, then it will take some more time. Okay, now you can see it is taking more time. So that's how we can do the cross validation as well as the hyperparameter tuning together. Okay, this is again the manual way. Now again we can check the scores. Okay, but this time we have done the cross validation. All right, then the scores will be much better. Because why better? Because हमारा data set is
Sorry
equally
for interrupting.
proportionate. Yes.
Hello. I have like in hyperparameter tuning. Basically, we are checking the value of eta for
Right.
every eta, and to pick up the best one, right? Like
Right.
this is hyper. यही है hyperparameter tuning के मतलब कोड तो समझ आ गया, पर
Mm-hmm.
हम क्यों कर रहे हैं ये, मतलब कि ईटा की बेस्ट वैल्यू के लिए सिर्फ, या
Right.
किसी भी अल्फा, सिर्फ ईटा की बेस्ट वैल्यू के लिए?
Here I'm just doing for the best value of eta. Okay, let's suppose हमने maximum iterations भी रख दी, different penalty values भी रख दी, L1 L2 elastic net, so we can also get the best values of that as well. I will show you that also. Okay, just in
अच्छा,
like
यानी
after that.
जो भी एस जी डी रिग्रेसर के जो भी पैरामीटर्स हैं उनकी
Mm-hmm.
बेस्ट वैल्यू के लिए, ताकि हम
Right.
बेस्ट प्रिडिक्शन कर सकें, राइट?
Right,
ठीक
right,
है।
right. So that we can make a best model, right? हम मैनुअली एक एक मॉडल पे स्कोर करेंगे, उससे बेटर है we can do the hyper parameter tuning. Okay,
ओके।
so that is the thing. Again, now we can get the minimum score. By this I'll simply copy paste this code here, and now you can see again I'm getting the same 0.001 as the learning rate. So this is just for the learning rate which we have done. Now like there are various parameters. There is a penalty parameter also, like where we pass in which regularization which we want to do. Okay, L1 represents the lasso, L2 represents ridge if I'm not wrong, and the elastic net basically takes both the values. Okay, then we have alpha value also, like जो भी हमारे penalty में जाएगी, like for the penalty regularization term जो भी होगी for that alpha value. So let's say alpha value like this 0.01, 1, 0.1, 1 and 2. Okay, now we have these many values. Abhi it will like it will take time. I will show you. Okay, so first we will check for each learning rate. Okay, then मैं एक और for loop create करूँगा for penalty. Okay, for p in penalty. Then I will create another for loop for alpha value. Okay, for a in alpha I'll write, I can write. All right, then मैं इस पूरे कोड को ना इसके अंदर इंडेंट कर दूंगा inside this for loop. All right, so that हम एक एक combination पे we can go through, and I'll simply pass on these parameters here. So for ETA I have the rate. For penalty I'm passing the p. Okay, and for the alpha value I'm passing a. Okay, so these are the hyperparameters which we have to tune right now. And this time मैं थोड़ा सा और इस पे like in the print statements also I'll do the tweaks, the learning rate here, uh, and here I'll write the penalty as well. So penalty p, and then I will write alpha value as well. Okay, alpha, and here a. Okay, so this, and this time like uh earlier we are storing the rate as the key, right? But this time we will store the tuple. Okay, the tuple which contains all the pairs, which means the rate, the penalty value, the alpha value. Okay, the same thing which we are passing here, I am storing the same tuple here. Okay, so that मुझे हर एक tuple के बेस पे score मिल पाए. Now if I run it, you can see learning rate 0.01 पे it will first check the penalty L1. You can see like it is still going on, and it has gone till all the combinations. To check the number of combinations also, what I will do is I'll simply set I equals to 1, I plus equals to 1, and okay, I'll write here combination. Okay, I'll simply write combination, and here I'll take the ith. Yes, that's it. मैं I को 1 से initialize करता हूँ. Okay, so you can see okay, not here. I should increment the combination value there. I plus equals to 1. Yes, So you can see combination 1 जो है, we have various combinations. If you see like अभी भी it is running, so we have total 84 combinations. How these 84 combinations? मैं आपको पहले like calculation करके दिखा देता हूँ. Like we have, okay, if I check the length of learning rate, this is the 7 learning rates we have, okay, and 3 penalties we have. If I check the penalty, so penalty, len of penalty, and if I check the alpha values as well, so we have these many values. All right, 7 learning rates, 3 penalty values, and then the 4 alpha values. All right, then it is basically creating the combination of each of the values, which means if here, okay, let me toggle it. Yeah, so for the learning rate 0.001, that is this one, okay, ये value के लिए it will first check the penalty as L1, then alpha की ये value लेगा, and here it is computing the score, okay, then alpha की value it has taken 0.1, then it has computed the score this, okay, same penalty values and learning rate के लिए, and then alpha की value 1 हुई, then 2, then जब alpha की पूरी values like it has gone through all the alpha values, then it will take for the same learning rate the penalty L2, okay, then again it will take the alpha value here 0.01, 0.112, and it will compute each of the score. So by doing this for all the like हर एक learning rate के लिए and हर एक penalty के लिए and हर एक alpha value के लिए, it will compute the it is doing the cross validation also, okay, with the CV5, which means 5 times cross 5 folds we have, and we are taking the mean value, and it is doing the cross validation and doing the hyperparameter tuning with cross validation for each of the combinations. And how many combinations we have? I'll simply copy it and multiply these values, okay, these many combinations we will have 84 here, you can see, and the same amount of combinations we have. So last combination मेरा है ये वाला, learning rate is this, and this is the penalty, and this is the alpha value. So you can see learning rate 1, penalty as elastic net, alpha is 2, okay, and for that we get this score. And now if I show you the scores dictionary, it will be very huge, okay, you can see like this is the scores dictionary. The key is this tuple, which is here the learning rate, then the penalty, and then the alpha value, and uska respective score as a value, okay. So okay, इसमें किसी को कुछ doubt, anything in the hyperparameter tuning with various parameters plus the cross validation? Is this clear to you all?
Yes.
All right. Okay. Now to again मेरे पास ये scores नाम की पूरी dictionary आ गई to check which pair is giving the best score. What I will do is I will take the scores dot items, and again मैं pair 1, that is the value, में value के base पे I will do. So मैंने value मैंने score के base पे I have taken the minimum value, okay. So minimum score जो मेरा मुझे मिल रहा है, that is in these values. So मेरा learning rate ये है, this is the penalty which is L1, and this is the alpha value 1, okay. So अगर हम यहाँ पे देखें this in this dictionary 0.01 with the L1, yeah, so हमें यहीं पे score मिल रहा है, like you can see, right, हमें पहले ही कुछ iteration पे हमें score मिल पा रहा है. So like the best values which we can say, so these are the best values. अब हम क्या कर सकते हैं? The conclusion of the hyperparameter tuning is we can take these values and we can train our final model, okay. I'll simply create a final model named SGD regressor, and here I'll pass the eta 0 as 0.001 and the penalty as L1, and then the alpha value is 1, okay. Then I can simply train the model, doesn't matter on X chain or X value, or I'll simply train the model on X and Y, okay. Then I can also compute the score as well, model dot score, and here I'll pass x. Let's suppose मैं validation के base पे score check कर रहा हूँ. Okay, so I'm getting the score in, sorry, I'm getting the score in positive, not negative. Okay, yeah, positive में I'm getting the score that is 0.00 something like that. So okay, let's suppose मैं exchange पे करता हूँ. Then okay, अभी भी काफ़ी बड़ा score आ रहा है. Let's consider okay x and y value only, and let's check the mean absolute error जो हम पहले से ही लेते आ रहे थे. Okay, and here in the mean absolute error I'll pass model dot predict x valid and here y valid. So it is giving me this mean absolute error. Now this error is different than this error. Why? Like this error we got via the average of all the cross validation. Okay, here you can see I'm taking the average of 5 cross validation, 5 folds of the data set. Okay, so that's why I'm getting a different error, but this is the, you can say these are the best values for this data set x and y. Okay, this is how we can do the hyperparameter tuning, and after hyperparameter tuning we have got this we have found the best model, and हम इस model पे predictions कर सकते हैं for the test data. Okay, so this is how hyperparameter tuning happens. Now the end goal is clear to you all. Guys, is this clear?
Yeah.
All right. Abhi, this thing which we have done here, this the number of combinations. Okay, this thing is the same as the technique which we use, GridSearchCV. Okay, GridSearchCV basically takes all the parameter values and create all the combinations, and it do the cross validation on all the combinations of the parameters which we have and train the model on it, and then gives us the score. Okay, ये पूरा जो code है, okay, except these lines I can like wrap this code up into a single line. I will show you now. Okay, how? So this this is the same technique for the grid search CV. What I will do is simply I'll write grid search CV. Okay, before writing that grid search CV I have to create a dictionary called parameters. Okay, so in the parameters I have to pass the parameters as the same name which I am having here, so eta, 0, penalty and alpha, and with these values I'll simply copy this, and in this dictionary let me write it as it is. Learning rate is eta 0. Yes.
सगळ्या जडच्या टाकायच्या आहेत का?
Sorry.
मला वाटलं की थोडं सगळ्या तरीच म्हणजे एवढ्याच किती जर्सी दोन प्रेस केलेल्या वर जे आहे त्या न्यायच्या, ह्या काहीच नाही न्यायच्यात का? काही राहू दे.
So all right, so हमें जो है ये parameters dictionary में ना we can't name anything different. Okay, something like learning rate or that, we have to name the same parameter name जो भी हमारा मॉडल में होगा. Okay, so eta 0 for the learning rate and penalty and alpha. Okay, this is same. So yeah, okay, so this is same, so I'll simply put it in a string. This is the parameter name. Okay, like this. Yeah, and it's there like these are their specific values जो भी हमें उसके parameters चाहिए. Okay, let me separate it by a comma. Yes, so this is the parameters grid which we got. Now in the grid search CV what I will do is, okay, first I have to import the grid search CV as well. Again, the similar to the this models this cross validation techniques, we have the grid search CV in the model selection module only. All right, so I will write the grid search CV here. Okay, and after that I have to pass on the parameter the estimator which is the model. I don't have to like write these values जो मैं यहाँ पे ऐसे लिख रहा था. Okay, okay, sorry for that. Yeah, so I don't have to write anything like that. I just simply have to call the model. So if I show you here, ओके मुझे बस मॉडल कॉल करना है, एंड आफ्टर कॉलिंग द मॉडल you can see I have various parameters. First is the parameter grid. Okay, after the estimator I have the parameter grid, which is this dictionary. Okay, the params, and then we have this other things as well, the scoring parameter. Scoring is similar to this negative mean absolute error. If I copy this, it will work, of course. There is no okay, double word wrap. Yeah, the scoring. Okay, let me simply copy that. This is the scoring parameter which we have passed, and then we have other things as well. You can ignore most of the things. The main thing is this CV. Okay, the CV is same as the CV which we have passed in cross-val score. It basically represents how many times or which cross validation techniques should we use. By default, if you see here in the CV, yeah, same as cross-val score. By default, if we pass on, okay, default it will takes like do the 5-fold cross validation using StratifiedKFold. Okay, or we can even pass like our custom KFold, something like this, KFold equals 5 or 3, or I can simply write it as 5. Okay, and that's it. Like we are missing with one thing, which is the data which we have passed here, x and y. How we can pass the data, I'll show you. This is the GridSearchCV, right? So I have to like, okay, I'll simply write it like that as of now, CV. Now if I run it, you can see I'm getting this GridSearchCV, something like that. Okay, CV equals 5, estimator as this, parameter grid like this, penalty, this is the parameter grid, the same dictionary. Okay, and then the scoring parameter, and this is the estimator, nothing different. All right, so now to fit our data into this, to do the hyperparameter tuning with the cross validation, what we can do is I have to simply call the fit function. Okay, which is for same for the model we have. If I simply call it cv.fit, you can see it is running, means it is doing the cross validation on all the parameters. Now like okay, abhi like here I have printed all these values, right, combination and all the stuff. To print all these values, what we can do is there is a verbose, there is a parameter called verbose, and it has different values. By default it is 0. If I set it to 1, and now if I run it, while fitting it, you can see each values, like fitting 5-fold for each of 84 candidates. So it will simply give us how many models we have at that. All right, so 84, again the same 84 models which we had earlier. All right, the 84 combinations, but not 84, we have the total 420 models. How 420 models? Because we are doing the cross validation as well, right, for the 5-fold. So it will multiply the 84 by 5, and hence we get the 420, which is the total number of models on which we are doing the hyperparameter tuning plus the क्रॉस वैलिडेशन. ओके, लाइक हम स्टार्टिंग में एक मॉडल से करते थे, एंड नाउ यू कैन सी वी आर डूइंग, we are creating 420 models. This is not a small number, and this is just a okay, this is just a basic thing, like we get okay. So अभी तक इतना clear है सबको? These 3 code cells, what we are doing and what we are getting. Is this clear to you all?
So basically यहाँ पे जो ग्रिड सर्च सीवी है और हाइपर पैरामीटर ट्यूनिंग है, वो हम इसलिए कर रहे हैं ताकि हम बेस्ट मॉडल ले सके, राइट?
Yes, best parameters ले सके for the
बेस्ट
model.
पैरामीटर्स फॉर द मॉडल,
Right.
इसमें डिफरेंस क्या था? लाइक आपने कहा था कि जिसमें हमने एक कोड था जिसमें आपने 3 लूप्स चलाई थी, कि वो
3
भी
loops.
सेम कोड है ग्रिड सर्च,
See,
वो भी सेम कोड है
yes,
इसकी तरह,
वही.
जो आपने अभी, तो इसमें मतलब डिफरेंस क्या है हाइपर पैरामीटर ट्यूनिंग और ग्रिड सर्च सीवी में, कि सेम ही है ये?
Okay, GridSearchCV is a technique to do the hyperparameter tuning. ठीक है? And what I have done here manually is the hyperparameter tuning only. बट इन अ ग्रिड सर्च CV मैनर. बट ये मैंने मैनुअली किया, राइट. मैंने सारे कॉम्बिनेशंस बनाए एंड आई हैव कंप्यूटेड द स्कोर. ऑल राइट. सो
Yeah.
मैंने ये मैनुअली किया. ये ग्रिड सर्च CV ही है, बट दिस इज आई हैव डन मैनुअली. ऑल राइट. दिस इज अ वेरी रॉ फॉर्मेट ऑफ, you can say, raw implementation of grid search CV. ठीक है. And the same thing we can do directly via calling this one. Okay, this function grid
Okay.
search CV. So either like and आपने वही पूछा कि मैंने यहाँ पे इतने loops चलाए. This is because for each of the combination in the grid search CV I don't have to like create any kind of loops. ये grid search CV अपने आप सारे combinations बना लेगा. All right. I don't have to do anything manually. Okay.
Okay. Yeah.
So that's it. Now is it clear to you all? These three code cells mainly, the grid search CV, how it is working. If it is clear, you can give a thumbs up so we can move ahead. All right. See, here I have set CV equals to 5. If I set CV equals to 3, then मेरे 84 candidates, 84 models होंगे, but this time it will fit 3, it will have 3 folds. Okay, so hence we have less number of models. Earlier we had 420 models, but now we have only 252 models. So this just simply depends on the CV and the number of parameters which we are passing. That's why, like, okay, how many of you are doing an MLP project? All right. So आपने प्रोजेक्ट में इफ यू हैव डन हाइपर पैरामीटर ट्यूनिंग, आपने देखा होगा आपका जो हाइपर पैरामीटर ट्यूनिंग है, इट इज टेकिंग अ लॉट ऑफ टाइम. This is because of the same reason. If I set a lot of hyperparameters, let's suppose abhi to I have only these three. If I set max iter also, okay, like 100,000 or 500, okay, the number of combinations we have, okay, the more number of combinations we have, the more time it will take, because उतने ही ज़्यादा models बनेंगे. All right. So that's why it is suggested कि जो एक्चुअल में पैरामीटर्स हाइपर पैरामीटर ट्यूनिंग के लिए काम आते हैं उन्हीं के ऊपर ही हाइपर पैरामीटर ट्यूनिंग करो, बिकॉज इट इज कंप्यूटेशनली एक्सपेंसिव. ओके. तो यस.
Hello.
यस.
Is there mandatory that we have to use the cross validation
In the
or
project,
hyperparameter?
yes, in the project it is
Yeah.
mandatory. Like we have milestones too for the same, and we have like I think 5 marks for each of that, like 5 marks for hyperparameter tuning and 5 marks for cross validation. Okay.
Okay.
So that is mandatory, of course. So okay, now I have this parameter grid parameter dictionary of 4 different parameters, and like earlier we had only 84 different candidates, right? Early 84 different models. But this time now if I run it with the default value CV equals to 5, and if I fit it, you can see fitting 5-fold for each of 252 candidates, totaling of 1260 models. Okay, means हर एक fold के लिए it will take each combination of these each parameters, and it will compute the score and do the model fitting. Okay, and at the end it will find the best model. So the same thing I have written this just to prove कि जितने ज़्यादा parameters you will
Yeah.
create, the more number of models you will get and the more time it will take. Yes.
Some small query, like जो params हैं जिसमें आपने values दी हैं, eta penalty, ये values इतनी होती हैं कि और भी हैं, काफी है. मतलब ये आपको कैसे, मतलब हमको कैसे पता चलेगा कि like eta में 0.01 है, उसके बाद 1 है, कि और भी values आ सकती हैं?
See, if I simply for this you can see the documentation of the model. Okay, if I show you the signature, यहाँ पे if you see for the penalty I have these 4 values. Okay, either L2, either L1 or elasticnet or the none. Okay, मैं इन चारों में से कोई भी वैल्यू रख सकता हूँ. Okay, so here I have set these 3 values. ठीक है. So And the same thing for the eta. If I show you here, yeah, eta basically takes the float value, and the float value default is 0.01. It will like the float value mainly it should be under the range of 0 to 1, so that's why I have taken these values. Okay, so that's the thing. ये जो values है that depends कि model कौन सी values ले रहा है, मैं कोई random value नहीं रख सकता, that depends upon the
तो मतलब
model value.
मेरा मेन मोटिव ये था कि इसमें पॉसिबल वैल्यूज क्या क्या आ सकती हैं।
For the
तो
eta, possible values are in the range of 0 to 1 mainly. अब 0 उससे भी ज़्यादा रख सकते हो, but the value should be in float. Okay, the learning rate can be bigger. Okay, but that will obviously overfit the model, nothing else. And आप कोई the range of values वो आप main documentation पे देख सकते हो. In the documentation you will get the exact range. Okay, कि कितनी आपको values रखनी है. So
Thank you.
I just have like I have shown you the demo and the implementation how it works. Mainly everything is like subjective, everything is based upon the model which you are using, the parameters which you are want to hyper like to tune, do the hyperparameter tuning, and the number of cross validation, the KFolds you have to do, so that is subjective. Okay, just one thing, by default यहाँ पे CV5 है and verbose मैंने 1 रखा, so I'm getting only this value. Let's suppose मुझे ऐसे ये same पूरा like ऐसा all the combinations के लिए I want the scores. Okay, so I want to see the scores. I will set the verbose as 2. Okay, now if you see मेरे हर एक क्रॉस वैलिडेशन के लिए that means मेरे for I will get all the 84 output in all the 84 combinations. So it means for the alpha value 0.01 and the eta this, penalty this. Okay, total time it is checking. Okay, by default it will show the number of combination, the total combinations and the time it is taking. Okay, now if I want to see the score as well, I'll set verbose as 3. Okay, now here you can see I'm getting the score as well here, and with the score for each of the fold, the cross validation fold. Okay, हर एक fold के लिए भी I'm getting the score. Earlier in the manual for loop I am doing the mean, right? But यहाँ पे कोई mean value नहीं, हर एक fold के लिए I'm getting the score. And if you see output is very big because for each combination it is doing the cross validation as in like for the 5 folds. So that's why that you can see by the verbose parameter only. By default we set the verbose as 1 to mainly see how many models we are fitting. Now to go further, like manually we have done like this, right? And uske baad we have found the best values like this way, and then we have to train the model manually, right? This is the manual hyperparameter tuning and cross validation. अगर हम इसको grid search CV से करते हैं ना, then by default the CV will store the best model. Okay, so we can do this, we can do something like this as well, cv.predict x valid. Okay, and then it will give us the prediction. Or if I do the cv.score as well, and here I have to pass, okay, not x valid and y valid, it will give me the validation score. So this is the validation score. Of course it will be in negative because जो यहाँ पे है I have passed scoring as negative mean absolute error. Okay, I don't have to create a model. Like अलग से मुझे कोई मॉडल बनाने की जरूरत नहीं, something like that. CV by default takes the best model. Also हम इससे और भी values ले सकते हैं. Like there are other parameters as well for the CV. If I show you CV, if I write CV dot best params underscore, it will gives us the best parameters. Okay, best parameter is penalty is L2, and the ETA is this, that is the learning rate, and the alpha value is 2. Okay, for these many candidates. Okay, and this is how you can get the best parameters, and you can also get the best estimator, that is the best model. If I write best estimator underscore, I'll get the best model with these values. Okay, so like this alpha 2 ETA 0.001, and penalty is by default L2. If I show you STD regressive, yeah, by default penalty is L2, so we don't have to explicitly like set the penalty as L2. So हम ऐसे भी करके like dot score something like कर सकते हैं, okay, और ऐसे भी कर सकते हैं. All right, so this is giving a different score. Okay, so I think that is the mean score and that is, yeah, normally आपको जो है model अगर चाहिए, you can simply do something like this, like model equals cv underscore cv dot best estimator underscore, okay. So आपके पास final model आ जाएगा, and then ये model आपके पास आ गया, you don't have to fit on this model, okay. The model is already fitted, you just have to compute the score on it. That is like either you can do the prediction or you can calculate the score. All right, so this is how you can do the cross validation using GridSearchCV. So is it clear to you all? Okay, so now one last thing, again we have like various hyperparameter tuning techniques. There is one more technique called RandomizedSearchCV. What this RandomizedSearchCV do is, like GridSearchCV में we go through over all the combinations, right? हम एक एक combination पे जाते हैं, but in RandomizedSearchCV it will randomly pick some cross validation, okay. It will randomly pick some cross validation, some parameters, okay. Like here we have these parameters, right? GridSearchCV basically creates all the combinations, but RandomizedSearchCV, let's suppose RandomizedSearchCV picks up this value 0.001 and this penalty and this value, okay. So ये बस इसी के बेस पे ही, और like some certain amount of values. So let's suppose मैंने इतने सारे parameters pass कर दिए, but it will only take these three values from here and these two values from here and these three values from here, and इसी पे it will do the hyperparameter tuning, okay. So that is the difference in RandomizedSearchCV and GridSearchCV. RandomizedSearchCV का एक flaw ये भी है, as it will take any random value from the parameters grid, so it may skip the best value. All right, let's suppose, okay, here we are getting the ETA as 0.001, right? Let's suppose I have called the RandomizedSearchCV on these parameters, and it has taken these ETA values, okay, these ETA random values. So then it will skip these value and मुझे best hyperparameter नहीं मिल, like best hyperparameter values नहीं मिल पाएंगे. So it often suggests कि you should use GridSearchCV, okay. And you can use RandomizedSearchCV when you have like a large number of parameters, okay. Here we have only like 3 parameters and like total 84 models. Let's suppose you are creating 100 or 200 models, then using RandomizedSearchCV is better, okay. So I just have to show you the intuition behind it. So is this clear, the RandomizedSearchCV? Okay, so that's it. Now yeah, now let's, okay, this is like all about the week 5, okay. अभी तक हमने जितना करा, this is the complete week 5 stuff. Okay, so should I do the week 6, this classification metric, should I cover this up in today's session or should we do this in next session? What do you guys suggest?
Like, anything you want, like.
Okay.
Not from my.
Okay, it will take 1 more hour also, so I think it's better कि हम next session में कर लें. I will show you a glimpse of it, okay. So like till now, till week 5 we have done only the regression, we have only we did everything, we did the modeling only on the regression problem, okay. And in the regression, specifically linear regression only, okay.
I was like exploring like week इन ऑफ एमएलपी, उसमें पॉलिनोमियल रिग्रेशन भी था, लाइक वो हमने कवर कर लिया, आपने करवा
Yes,
दिया वो?
polynomial regression is same as creating polynomial features, then calling the linear regression. Okay, कोई difference नहीं है. Polynomial regression is same as creating the polynomial features and then calling the linear regression model. All right.
Okay, yeah.
So yes. Okay. Uh, then we have this classification also. We have mainly two kinds of problems. One is the regression, the second is classification. In regression we compute a continuous variable like house price or temperature or kitni rainfall hogi, right? Rainfall in millimeters or something like that. But in classification we do the classification mainly. Let's suppose we get a picture and we have to identify whether in the picture there is a cat or not. Okay, so we have to classify. Or let's suppose we got like cat or not, we can say like for 0 we can say there exists a cat, and for 1 we can say, sorry, for 0 we can say no cat is there in the image, and for 1 we can say there exists a cat. Okay, so this is how classification done. And classification may majorly, like we have a lot of subtypes, like we have multi-class classification and we have
इसमें हम
multi-label classification.
एग्जांपल ये भी दे सकते हैं, लाइक जैसे कोई मेल है वो स्पैम है नहीं है, लाइक
Right,
उसमें हम
right, right.
क्लासिफाई कर दिया.
Yes. Okay, let me give you some more examples. Let's suppose हमारे पास एक mail आया. We can train a classification model and we can check whether a mail is a spam or not spam. The same this classification techniques generally used by a Gmail and various mail services. Okay, जो क्लासीफाई कर लेते हैं हमारे मेल्स को बाय ऑटोमेटिकली कि वो स्पैम मेल्स हैं या नहीं. ओके, and we can also have, let's suppose, the famous one classification technique, like example is MNIST dataset. MNIST basically, MNIST has a numbers, it has a handwritten digit recognition dataset. Let's suppose I have a few handwritten digits here, 0 1 2 3 4 5 6 7 8 9. Okay, this is the MNIST dataset. It has various images of various handwritten digits, like all the digits from 0 to 9, but in various formats. Let's suppose 0 is closed here, but in some 0 is something like this, or 0 is like this, or 0 is big. So basically we have various amount of data, or one like this, or one like this, or let's suppose one like this, and two something like this as well, 2 as well. Okay, and 4 mainly we can have like this, we can have like this. Okay, so this is the MNIST data set, and we do this classification as well uh, on the MNIST data set. That is the very famous data set, you can say, for the classification stuff. हम इसमें क्या करते हैं, we have various images, like as a, you can say, we have a image, okay, a square image in which we have the images in the white color. That is the basically black and white data set. If I show you this data set, something like this. Okay, this each black box represent an image, and उसके अंदर जो ये white color से that digit represents कि ये कौन से digit को belong करती है. And that on this thing we mainly create a classification model, and we take in a image. Okay, as a test data we take in a image, and our model has to identify वो जो digit है image में वो कौन सी है, whether it is 0 1 2 3 4 or 9, up to 9. Okay, and yes, in classification we have multi-class and multi-label classification. Before that, like we also have this binary classification. Okay, binary classification, as the name suggests, it classifies in two values. Either it is 0 1, like either there exists yes or no, or something like that, or you can say -1 or 1. Okay, or something like that, anything like any labels. But if the labels are like, if there are only two discrete values, then we call that problem as binary classification problem. Okay, so then we have multi-class classification. Multi-class MNIST dataset comes under the multi-class classification, where we have to identify multiple classes like 0 to 9 digits. Okay, or let's suppose we have a like the same thing, like okay, let's suppose we have various food, we have the food data set and their respective ratings. Okay, ratings are in the range of 1 to 5, like either 1, 2, 3, 4, 5, and we rating is the target label. So this comes under the multi-class classification because we have multiple classes. Okay, something like that. Or let's suppose we have images, and in the images we may have dog, cat, human, or something like that. So that is also multi-class classification. Okay, this is just a basic. And then we have multi-label classification. Multi-label, what is multi-label? Multi-label is mainly like, let's suppose मेरे पास एक image है, and in the image I have trained a model. Okay, okay, let's suppose I have an image, and in the image I have the like a road as well, where I have some cars. Okay, and I also have some humans, something like that. I also have some dogs and cats. Okay, let's suppose this is a dog, or and let's suppose this is a cat. Okay, so we have a lot of things in the image, and that this kind of problems comes in the multi-label classification, where we have various labels, like we have to identify what type of car it is, and in the human we have to identify whether the human is a male or female, or like in the same image we have to identify other things as well, like whether it is a dog or a cat. Like एक image पे we have to identify a lot of things, like a lot of different kind of things, different categories you can say. That comes under multi-label classification. I'll show you one example also. Multi-label classification. um, okay, like this. On the right hand side you can see, like we have to classify whether it is a like there is a dog and there is a eagle, bird as well, right? Like animals as well as birds. So we have various categories: animals, birds, humans, and a lot. And in each category we have various values. Okay, so that comes under multi-label classification. So ये तो basic हो गया. Is this clear? I hope this ये तो आप लोगों को mainly पता ही होगा. So this is like a basic thing about classification. And then in the classification we have various models also, and we have various important metrics, something like accuracy, confusion metrics, precision, recall, and F1 score. This metrics, these all metrics are in the week 6. So can we do it in next session? Like the starting say we will do the classification thing. Is
Yeah,
it fine?
sure.
All right.
It's fine from my side.
All right. Okay. So अभी के लिए like do you have doubt in any of these things? Do you guys have any doubt like in hyperparameter tuning or cross validation? Okay. So I think that's it. So let's end the session today. And I hope like your week 5 is covered by like watching this session. So that's it, and thank you for attending the session.